get on the road to go home. Hello everybody, this is Almir. It's time for another episode of Commuting with a Software Engineer. Today we're continuing the topic of top 25 things needed to achieve the enterprise level of microservices. It's actually the last part of this microservice conversation. I already had 3 other videos about this. So today we're covering items 21 through 25. So number 21. Number 21 is the load and performance testing. You need to have this accomplished when you're doing enterprise level of microservices. Let's assume you have a couple of your microservices, microservice A, B, and C. In some ways they're talking to each other, or somebody outside is consuming your services. You really need to have a load test done on all these microservices and a performance test done on it. Performance test is really what is the average response time for each call. Is it 200 milliseconds? Is it on average 250 milliseconds? Or what is that number? You have to determine what is the performance or the average response of your API under normal load and under heavy load. But then the load testing itself is a separate thing. You need to perform the load testing, and you can use different types of frameworks, but the end goal is that over a period of time you need to apply a certain amount of load to your microservices, and then you have to hold that much load for X number of minutes and see how your system reacts. For example, you load it with X amount of load, and then you watch the CPU and memory performance on your microservices, and then you slowly keep increasing the dial or changing the dial, adding more load until you see the breaking point for your microservices. But you're doing this without any scaling out. So you have to have a limited or fixed number of instances for your microservice. And then that's the only way you can see how well each instance can perform before you can decide, oh, okay, I need to scale out. So the load testing should be done with a fixed number of instances for your microservices. For example, if you're running out of AWS, your microservice could be running in containers within your EC2 instances, and then you should be doing load tests with that type of setup with fixed number of instances. So end goal is you need to know what is the CPU and memory utilization on your instance where your microservice runs when you're running fine and just before the breaking point, and then what is the memory and CPU utilization when you reach the breaking point of your load test. So that was number 21, which is load and performance testing that you need to accomplish within your company if you're building enterprise level microservices. And this should be part of the regular process anytime you introduce a new microservice or anytime you're making change to the existing microservice. You need to redo your load testing and performance testing. Number 22 is the circuit breaker pattern that you need to have in your system, especially when your microservice talks to third-party APIs. It is in a way within your control if your microservice talks to another microservice that might be owned by some other team within your company, but it gets more complicated when your microservice talks to some external API and you cannot control the stability of that API. In that case, the circuit breaker pattern should be introduced in order to alleviate or avoid the back pressure to your microservice or to the rest of the systems in your platform. Let's assume that other external API is down and you keep constantly calling it. You're wasting resources. You may be actually reaching out to your database before you call them. So all of these resources are being wasted. It's causing pressure on your system, so the online customers interacting with your microservice for something else within that microservice may be impacted indirectly. So the goal of circuit breaker pattern is that if you see X number of calls failing over Y number of minutes, you basically open the open the circuit, which really means that you stop calling the third-party API, and then at some point you have to close the circuit and continue calling that other microservice based on the success, or maybe after when you open the circuit, you may, after X number of minutes or seconds, you may attempt to call that third-party API, and then if they're up and running, then you will close the circuit and then continue processing as usual. So that was number 22, circuit breaker pattern, that's especially needed when your microservice talks to a third-party API. Number 23, database design. Database design is crucial in microservice architecture. There is the code first mentality, and then there is the database design and structure first, and then you develop the API. If you're building microservices, I recommend that you use the code first approach, where you clearly define what the purpose of your microservice is, and then you define the database behind it, and the logic is all residing in your application code in the microservice, and database is just used for storage. But there is cases where you need the relational database, and you may design the tables first and then wrap the microservices around it. But you can still, even with relational database, you can design your microservice first, define the purpose, and then depending on what data you're writing, you can still use your relational database only for storage purposes, and all the logic could still reside in the microservice itself. But basically, this item 23 about the database design, it's you need to think about these things. There is no right or wrong here. You just have to know what problem you're solving. For example, you could use, if you're building services in AWS, there is the native Amazon DynamoDB NoSQL database that you could use. Your microservice could be saving data into that Dynamo and pulling that data out of the Dynamo using the hash key, sort key, and using the filter expressions. But if you have more complicated systems where you need to do fancy queries on the data, NoSQL database may not be good for you. You may need to go with the SQL or relational database. So there's no right or wrong. Depending on what problem you're trying to solve, you just have to understand it and consider it in your platform. And maybe you need to have some standards when a new microservice is designed or being designed. You need to consider which type of database is going to be used, instead of assuming that it's always one database that solves all your problems. Number 24. Number 24 is database capacity provisioning. This is something that has to be an ongoing process in your company for your microservices and the tables that your microservices use. And also at the beginning, if you're just starting to design your platform and enterprise level microservices. Let's assume you're using Amazon DynamoDB as the NoSQL database behind your microservice. You're required to define for each table the reads per second and writes per second, because that's how you pay for the service. You pay for how much you provision. For example, you don't want to provision a lot, because you'll be paying for something you may not be using, and you don't want to under provision, because then you need to be auto scaling your reads and writes per second for that Dynamo, and auto scaling may not be instant in your microservice. So it's best to do analysis, come up with some standard formula on how you arrive at the numbers for reads and writes, and then standardize it across the company or across your teams. But in order to define reads and writes per second, when it comes to NoSQL, you really have to know what your journeys are and how your microservice is used in the customer flow or in some backend flows. And then you can reverse engineer it and calculate and figure out what the database provisioning numbers are. So number 24 is you definitely need to think about database capacity and the provisioning reads per second, writes per second, or in the case of relational database, you have to understand how much storage you will need. So these are type of things that you need to have as part of the process anytime a new microservice is designed, or anytime a microservice changes are made, and especially the database behind microservices change. When it's changing, you have to reconsider the database capacity numbers. So the last item, number 25 out of the top 25 things to achieve the enterprise level of microservices, 25 is the data structure, governance, and reporting and analytics. Reporting and analytics typically gets forgotten on projects, but you definitely need to include it from day one you're designing your microservices and the tables behind microservices. When you design that table behind a microservice, ultimately that data, you have to have some mechanism of streaming that data into some reporting database where you can do some more fancy analysis and create reports on top of that data. In terms of the data structure governance, it's very important here, especially when it comes to NoSQL databases. The logic of the business logic is sitting in a microservice, and NoSQL database is just storing JSON objects for you, and when you need the data, it's pulling those JSON objects. So all the logic is in the microservice, and even though it's a NoSQL database, there's still some structure to it. You have the hash key, you have the sort key, and then you have the remaining attributes that could change. But at the end of the day, you have a microservice that has some model classes that define the structure. That data will be serialized and saved as JSON in the NoSQL database. So really what you have to govern here is your Java model classes that will be serialized into the database, or C# model classes that will be serialized into the database. So you have to carefully govern the changes in those model classes. If somebody goes in and changes the definition of an existing attribute, that should not be allowed, because you're not going to be backwards compatible. It would be even good to have some automatic way of detecting when changes in GitHub are done on these model classes, to send emails and notify the database experts so it can initiate a conversation. But the team should be aware of this ahead of the time. Anytime when you touch those model classes in your Java, C# code, or Python code that is writing to your NoSQL database, you need to initiate a conversation with your database experts. So that was item number 25, the last item out of the top 25 things to do in order to achieve the enterprise level of microservices. I hope you guys liked my videos on this. So basically I covered these 25 items in 4 sessions. You can find all the details actually that I covered in these videos about the 25 things for these microservices in my blog. I'm gonna have everything in the description of this video. You can click on the link and go read the full description of all 25 items. Maybe I missed something in the videos, but you can definitely read it in my blog post. Thank you for watching. I'll see you in the next episode, and keep geeking out.